Hey class, this is Gigi. We are going to go over the product rule for taking the derivatives, okay? So from the previous lesson, you know that the derivative of a sum is the sum of the derivatives. And it'll work the same way with subtraction. The question here we want to ask is, what if you have a product? Meaning, what is the derivative of a product? Is it, and I'm going to put a question mark here, is it just taking the derivative of the two functions and multiply them together? That's the question that we want to know, right? So to investigate what's happening here, we will go ahead and take a look at this example here. So suppose you have f of x is equal to x to the fifth. So then the derivative is 5x to the fourth. And then g of x is x squared. So then the derivative of g is 2x. Now, if you go and you take two derivatives and multiply them together, you will get 10x to the fifth. Okay, now, so let's actually go and look at f times g as a function. So what is f times g? F times g is x to the fifth multiplied by x squared, which is x to the 7th power. Okay, now, when you take the derivative of x to the 7th, which is the derivative of f of x times g of x, right? That's the derivative of f of x times g of x, is the derivative of x to the 7th. And we know the derivative of x to the 7th power is 7x to the 6th. Now, if you go and compare these two, you say, no, they're not the same, right? So what can you say about the derivative of a product? Is it the product of the derivatives? And the answer is no, it is not. And here is your counterexample here. The question, though, is, well, if it's not the product of two derivatives, then what is it? Okay, so let's go ahead and take a look at the derivative using the definition. Okay, so if we were to use the definition of derivative, we would say the derivative of f of x times g of x is going to equal to, by definition, we would write limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x, all divided by h, right? That's the definition of limit. Take the difference quotient and then take the limit as h approaches 0. Now, I'm going to go ahead and copy down that limit. And I'm going to apply this one little nifty trick here. F of x plus h times g of x plus h minus f of x times g of x, okay, all over h. That is what we have right now. Okay, now you would be thinking, well, why am I writing that and leaving room? What I'm going to go do is I am going to add 0 to the numerator. Because when adding 0, it wouldn't change the value of the numerator, okay? And what is 0? 0 is this right here. Here's my 0. G of x plus h times f of x plus g of x plus h f of x. Why is that 0? Because I add and then I subtract it right out. Let's do that again. I'm going to go ahead and add 0. Okay, here is adding 0. Negative g of x plus h times f of x, positive, the same thing, g of x plus h, f of x. So that right there is adding 0. Now you may wonder then, why did you just do that? Well, here, I'm going to start grouping things together. I'm going to group these two red terms together, and I am going to group these two blue terms together. Okay, factor by grouping, yeah? I think that's something that you've learned in college algebra class. So limit as h go to 0, and I'm going to go ahead and even split the limit because we know limit of a sum is a sum of the limit. Okay. Now, what am I going to write on the numerator? For the two red terms, I could factor out a g of x plus h, and when I do that, I will have f of x plus h minus f of x left in there. And then for the blue terms, I would factor out f of x because that's the common factor. When I factor out f of x plus h, what do I have inside? Well, if I factor f of x out, I will have negative g of x that is left. So I'm going to write minus g of x here. And then when I factor out f of x, I will have positive g of x plus h that is left. Okay, now I'm going to change this to red color. Then I'm going to change this h to blue color. And you tell me if you recognize something. The red, the limit as h go to 0 of this red right here, that right there is the derivative of f of x. Multiply by, well, when h go to 0, where does g of x plus h go? It will go to g of x because h is approaching 0. So x plus h is approaching x. Plus, okay, in the green, the limit as h go to, in the blue, the limit of as h go to 0 of g of x plus h minus g of x all over h, that right there is the derivative of g. And when h is approaching 0, where does f of x go? Well, f of x is still going to be f of x. So then we will say this right here is the derivative of f times g. Okay, so what is the derivative of f times g? It would be the derivative of f times g of x plus the derivative of g times f of x. And I would say the derivative of the first times the second, derivative of first times the second function, plus the derivative of the second function multiplied by the first. Okay, that is the product rule. Okay, now in order to do some application of this, we will take a look at, let's take a look at this example here, where where we only are going to be using polynomials, because we all know how to take the derivative of a polynomial. Okay, so suppose I would say let y equal to say x to the 7 plus 2x to the third multiplied by negative 3x squared plus 4x plus 5. Okay, now that's a very long polynomial, and you don't want to multiply it out, even though you can multiply it out, right? But to demonstrate how the product rule works, I would say then the first part right here is your function f. The second part right here is your function g of x. So then you would say the derivative of y with respect to x is, and we write that as dy dx, is, right? So according to the product rule, we would say it would be the derivative of f of x times g of x plus the derivative of g of x times f of x. Okay, that is the derivative of the first times the second function plus the derivative of the second function multiplied by the first. That's the product rule. Okay, and we're going to go ahead and apply that. So the derivative here is going to equal to the derivative of f of x, which would be 7x to the 6 plus, bring the 3 down, you would have 6x squared multiplied by the second function, as is, negative 3x squared plus 4x plus 5 plus the derivative of the second, which would be negative 6x plus 4 multiplied by the first, which is x to the 7th plus 2x to the 3rd. So that is how you apply the product rule. And if you would like to, you can go ahead and distribute these terms out and get a very long polynomial and combine like terms to clean it up. But I will not do that here in this video. This is just demonstrating how the product rule works.